Hello everyone, Mike here. I'm looking at a 12 volt DC power supply. It's a switch mode power supply that takes mains voltage here and 110 or 120 and AC and output say 12 volts DC are here. Now I have a project that requires 13 volts and I don't have a 13 volt supply. They come in 12, 15, 5, 9 standard values from the manufacturer, but they do not come in 13 volts. Now, I could use a boost converter, or I could use a 15 volt with a buck converter, but I thought I'd modify this one here to output 13 volts. Now, looking at this power supply, uh, you got your neutral and line connected here. So AC power comes in through this bridge rectifier and it gets stored in this capacitor here. Then this IC will pulse the voltage through this, or the current through this transformer to the output. There's a feedback circuit from the output back to the input through this optocoupler right here. And the way it works is that the output voltage is sampled over this voltage divider. It's made of two resistors and 11.5K and 1.5K. Let me see if I can zoom in and show you the values. Yeah, you can make the 1501 over here and 1152 over here. So the output voltage is sampled. This would be the VCC, this would be ground, and this voltage here would be 1.41, which is fed into the optocoupler here, and then the transformer will keep regulating the output so that it sees a 1.41 volts here. Now, if I change this voltage divider by, say, increasing this resistance so that a 13 volts on the output will result in a 1.4 volts here, then theoretically this transformer should output 13 volts, which is what I wanted. Now, you gotta be careful when you're working with these transformers. They connect to AC main, which could injure or kill. So very careful with that. Also, this design uses a voltage divider. Another design may not. So you need to know what you got at hand. For example, let me show you. I have a 5 volts um, power supply. Uh, you can see here it says 5 volts. And it's from the same manufacturer. But if you look closely here, the feedback is done through this chip, which is a DK450, and this is a precision 5 volt regulator. So different supplies, different designs. You be careful what you have, and if you need to modify it, take that into consideration. So the setup on the power supply is that a VCC here of, at the moment, 12.27 volts would result in a voltage over here of a VD equal 1.41 volts. And that would drive the optocoupler. This would be pin 1. That dashed line here is the optocoupler. Now, when the circuit is in operation, this voltage would be actually more like 1.028 volts. And that is because this is the forward voltage across the diode over here. Now, if we don't look at this and we just focus on that, we want to change the resistors so that a value of around 13 volts will produce this drop of voltage, 1.41 volts. And if you do the complicated math of a voltage divider, you'd find that adding a 1 kilo ohm resistance here in series would give us that result. So let's first compute VD at 12.27. VD would be 12.27 times 1500 divided by 1500 times plus 11,500, and that would equal to 1.41 volts. Now, if we add 1,000 ohms here and we compute the value of VCC, that would result in 1.41 volts. It would be VCC is equal to the current going through the resistors, which is 1.41 divided by 1500, multiplied by the total resistance, which is 1,000 plus 11,500 plus 1,500, 14,000. And that would give us a value of 13.16 volts. So let's take this to the bench, plug the power supply in, measure the voltages before, do the mod, measure it after, and see the results. Okay, so it's on. I can see the red light at the bottom. And right now the output voltage is, that's AC, DC there, 12.27. And if we measure the voltage at, let's say, over here, one volt. If we measure voltage here, 0, 12, and in between also 1 volt. So the output here goes here. The best way to do this modification here is to replace the 11.5K resistor with a 12.5K resistor. Unfortunately, I did not have a 12.5K resistor on hand, so I had to improvise and literally add a 1K resistor in series with the existing resistor on the board. Remember, this is rated to a certain power. At 12 volts, you could get 700 milliamps out of it. At 13 volts, you're going to have to reduce your maximum current that you get out of it to stay within the power limitation. Okay, here's the moment of truth. Let's see if it's going to work. No explosion, that's a good thing. And now 13.26, there you go. And the voltage over here is 10.26. So I got myself a 13 volt switch mode power supply from the 12 volts just by doing this little modification with the resistors. I hope you found this video useful, and as always, thanks for watching.